Hi, we are there. Let me start. WebAssembly programming is the current topic, and that will be show and tell and some practice. Hi, we are there. Okay. Let me So firstly, because this is web development with C++, and for that we'll be using browser. So I will create new window. Okay, we have it, and I will go to the website webassembly.org. So this is the starting point for WebAssembly. And what is WebAssembly? This is technology that allow to build applications in many languages, actually, that can be ported to the WebAssembly, in abbreviation wasm, that will run in near real time on the client side in the browser. So browser is let's say gating the what capabilities computer on the client have, so that allow to build TIC clients with this technology. And technology was built by W3 consortium with Mozilla, Apple, Google, and Microsoft. And yeah, this is the stack machine. So that means that it used the pattern of FIFO, means first in, first. Sorry, LIFO. That's LIFO. So last in, first out. So what is on the top is taken out, and then the second part from the bottom of the stack. So mainly this is the stack definition. So you can check more details there. And if we go to getting started, so for C, C++, we have that reference to MDN web docs, and we can see that WebAssembly tool like Nscripten can be used, and we will be using that one. So you can go also to nscripten.org, and from there ready to get started. So download and install the SDK. So this is our software development kit, and actually I won't be doing those steps. I did it some time ago. So if you are planning to try it, so there are the steps. So you need to clone the repository, you need to update, you need to install latest, activate, and activate the environment that we will be using. So you can check the informations there. Actually, that website has a lot of information, and we'll be checking that in this stream as well. But there is much more to be checked. And yeah, I will open Visual Studio. So our new window. So I have empty workspace, and that will be much quicker introduction, but yeah, that will boost your development and checks on WebAssembly. So probably some issues, you can omit some multiple issues trying that. So firstly, of course, I will create C make paste txt, and I will create folder for sources, and I will create folder for build, and I will open terminal and one more for build. So if I will echo my path, I should have a link to MSDK upstream mscripten and MSDK. That's my catalog. So I have that installed, and I will show you what is there with Midnight Commander. So this is libraries, web, MSDK. So in the upstream mscripten, so we have EM++ compiler and EMCC compiler. This is the front end compiler, and it is built on top of Clang, LLVM, low-level virtual machine. And what is mscripten? So what we have sources where we have the glue code, which is JavaScript. So WebAssembly is faster than JavaScript, but the browser, the native script is the JavaScript. So there are libraries that are ported through JavaScript as well, and sometimes your features need to have such glue code. You can actually check what is built already, and I'm sure this is evolving. And the second important catalog is tests. So in test you can check the examples, so you can see what can be built and how it works. Of course, from the webassembly.org and mscripten.org, you can check more details. Okay. Okay. So firstly, I will create our main.cpp. I won't be creating the header, and let's see if we can use IOStream with Open Broadcaster Studio that I'm using to stream the live stream. And if not, we will use printf, but okay, we will see that. So the CMake minimum required version will be 3.13 because there is one function that is since that version. So CMake minimum required will be version 3.13, and we will set also CMake CXX compiler, that will be not ICX but EM++ in that case, and we set the standard for C++. CMake CXX standard will be 17. Okay, what else? We will set 6x flags and link options, so that will be strongly related to mscripten. Set CMake flags, and that will be string. So we will preserve what was there in case that will be the additional configuration, and we pass optimization, so that is in the string O3, and I've mentioned in the post that the plan is still to utilize SIMD, and mscripten supports that for 128 bits and different set of instructions. I will just configure, but we won't be using today as this is not the most important topic at the beginning. The topic is to configure and run example actually with concurrent threads, the simple version, and in next streams let's prepare more advanced with some SIMD instructions. I will show also in the website how to find information about that, but to pass it's MCD1A28, and we will pass also SSE 4.2 as we have modern laptop, and MAVX. Okay, so that will be used in the future, but already will be configured. And the second part is link. So our parameter for linking, and we also preserve if there are some previous link options, hours, and what we'll be using there. So passing parameter to unscripted is with S, and we'll use P threads, which is POSIX threads. Use P threads. We'll use proxy to P threads. It can be one, but default is one, I believe. So so you can omit that. And proxy to P thread is to run the main thread in separate worker. So browser currently support web workers API. So you can also run scripts in separate threads, and this is how it works in the browser. So we use our main function. I will define it. So that our main function will be run in separate worker. So actually browser main thread will be released. So this is one of the ways to use it. And what we pass also, I will do that in that way. That will be so we mentioned the pool size, and this is navigator hardware concurrency, and I can show you also show that I have so I have 8 cores, CPU's 8, byte order is little endian, but this is not well, this is important, but but let's leave it. So we have 8 cores, and if I will open console, I will hardware concurrency. So the 8 threads is supported. Okay, so I will copy to have the proper information. So our browser also supports the threads we have. Okay. And what other configuration we need? Allow memory growth. So actually you can extend your memory if you are so you can create the function in JavaScript, and you can pass that to to WebAssembly module, and in that case the table, virtual table, and the table of methods that and functions that can be used will grow. So actually mainly that will be the standard memory size, and will not allow to grow above the initial memory. Okay, and we put initial memory will be 128 megabytes, and actually I will add one more. It's assertions. This is not for production. This is for testing, debugging. So that will show more information in browser, and actually at the beginning it's good to have it. And let's say these are our link options that we will pass to the linkage process, and then we define project that will be stream number 4, languages, that's C++ just, and we will set our sources that will be src main.cpp, that way. Okay, and there's new one that is CMake executable suffix, and it is .js because we are creating our JS script with WebAssembly, and executable that will be, let's call it script, and we will pass sources. Okay, and then target link options, so that will be script, public, and close there, and this is our link options variable. Okay, and target link libraries. What libraries we'll use? So we link to script M. This is for our instructions. Library M, standard C++, and pthreads. Okay, I will go back and I will show if we type actually compiling, porting. So you can go to use SIMD with WebAssembly. Actually, if you read that, you will learn how it works and what preprocessor instruction you can use to gate the code, and additional details. There is a lot of what methods are supported. So from previous string you know there is a lot, but WebAssembly doesn't, and mscripten actually doesn't support it. All of them. I was checking that works on WebAssembly and mscripten are still in progress. So you can expect it will have a better coverage, but probably there is sufficient number of functions, methods that can be used. What you won't be checking now. You see there is a lot, and yeah, there are additional details about that. The pthread support, so it is also there. So there are flags that we are passing, pthread size, pthread pool size, and so on, proxy to pthread, so you can check that there as well. And I haven't mentioned, so there is tutorial also with some simplified version, but in test catalog you can find more, so how to compile and such thing, and how to use simple direct layer, simple SDL library with that, and how to use files also, and how to compile with the file that you need. And if you as output need HTML or JavaScript. Okay, yeah, I encourage to check that website and read. There's a lot of information. Also, in the WebAssembly developer.mozilla.org, actually how WebAssembly technology is built, and what interface it uses, objects, and such things. Okay. What else? We go to main, and our includes. First will be ion stream. Second will be thread and chrono. We'll use chrono for sleeping the thread, so the milliseconds that will be from chrono, and okay, so we'll create thread function that will take integer ID, and that will be simple loop up to 5. Okay, and we'll just print out information. Thread ID working, and what we are passing is our product standard end line, and we will sleep current thread with this thread, because another way it will be too fast to see that and read the information we want to see. Standard volume milliseconds, and that will be half second. Okay, and we have main, and we will run in the loop actually. So I will create void loop function, and there we will define 2 threads, T1, and we will pass our function to the thread, and the parameter to the function is done that way. And I will copy that. We have T2, that will be we have ID2, and we need to place barrier join T2. So actually when it ends counting to 5, so that barrier will prevent from releasing, and actually the function will take when the threads will stop and our loop. Okay, for our loop we need include scripten.h. So and there if the and if, and there we will use scripten set main loop 0 is we don't set the frame per second, and we set 1, which is infinite, and this is our simulate infinite loop FPS, and we pass the function that we want to loop over. And you can, of course, if you use, I can get that here as well. So you can compile for standard G++, and with EM++ you can compile to mscripten to WebAssembly actually. So you can tell what version you want currently. Okay, so this is the simple example to run 2 threads, but in infinite loop. Okay, and there we need to go to build as well, and I will create one more folder for wasm. Okay, and Cmake, let's see if we configure it well, and make set main loop. Mscripten. Why this is undefined? We place mscripten there. So what's missing? We have EM++, script. Okay, so if I will, and let's rebuild. And set main loop. Mscripten. Not same. Okay, so we have our script and our wasm. It's strange that we can't use the API currently. But okay, let's check and maybe I will fix that. So what we need HTML index.html to run our script. And let me just copy example. This is a very simple example. So we are loading our script, and we will load it in the bottom. And important is module that on runtime initialize. So that will load in share array buffer our module. And actually, if you create the functions and you will expose it, so you will be able to use it from the module. But that will be, let's say, in next stream. Currently, we will just look how to run the simple application. And firstly, we need HTTP server. So I will use module HTTP server, and I will tell you that it won't work. But I wanted you to show how it should be. So we have HTTP localhost address 8000, and you see that the worker is not able to work because share array buffer transfer requires self cross-origin isolated mode, and for that actually we need to run that in different way. So we need to modify. We can't use HTTP server as it is, but we need to put the headers, the response headers. Server.py. And I've already prepared that simple server where we are passing cross-origin embedded policy, require corp, and cross-origin opener policy, same origin. I will show you article from Qt, because Qt can also be ported to WebAssembly, and there is good article that describe how it should be. Okay, so currently I will run script Python server, and let's reload. And now you see that module is not defined. Okay, but our worker start working. So you saw actually that what we put in the standard out is translated to console log, and in the network what was loaded. So our script and our wasm was loaded without issues, and in response you can see this is a textual format, and actually you don't need to write the textual VAT is the VAT format. So you can of course try, but yeah, that mimic real assembler, but because it is browser based, so this is WebAssembly. So this is the format that WebAssembly use, and this is textual mode for human beings, but the wasm is binary format. This is just let's say representation, and scripting adds a lot of different things. Usually the methods are simple, but yeah, the framework is huge, and yeah, because we are using also worker threads, so that's adding overhead to the runtime. I'm just curious why I was not able to use that loop. set main loop. Let me compile again. Use of undeclare. Okay, and if I will, let me just restart the window. Keys. Make. There is some issue I haven't had, but okay. Maybe I won't be fixing that now. And script. I'm scripting. Now I see. Okay. So again. And I will remove that. I will copy that. Okay, and with sources, and you see 1, 2, 3, 4, 5, 6, 7, 8 threads are waiting. Go to the console. What's happening? Okay. The server is not working. Okay, oops, sorry. Let's refresh page. So it will run in the loop. But one more issue. Why? Okay, if we put that on top. Okay, so on top is better. Yeah, so we are running threads there. It's 40 minutes for this example, and what I wanted to show also, it's cute WebAssembly. So this article, it shows how to utilize Qt with WebAssembly. Is not easy, as you need to choose your modules and prepare that. But there are informations. I wanted to show. Yeah. So multi-threading. This is explained well, that share array buffer is used, and you need to use COOP and COEP headers to use share array buffer there. And the CMD, but actually the whole Qt framework for building desktop applications, so you can move your desktop application to be run in the browser. In some cases, that might be well, very good idea probably for some companies, some projects. And yeah, there is more information, but this is mentioned how it should be. And actually, maybe I will show for this stream just one additional information. This is WebAssembly games.dev. No, let me check the address. WebAssembly, not dev, but com. WebAssembly. Okay. Yeah, so there are Angry Bots. I was checking Angry Box and Banana Bread demo, which is the Quake. I will just quickly open one, so you see that the Unity with WebGL was used in this, and I wanted to see what is loading. So we go to network, we load again. So no information. Yeah, but that should be actually. Okay, I will close that. And banana bread. Network. With that WebAssembly, so we should see well, that WebAssembly, but it uses workers. To be honest, I don't see wasp to be loaded, but well, it mentioned it is. So you show that actually in this example we have that wasm. So yeah, those are more advanced applications, so they made it better. All right, I think we can stop here. So mscripten.org, that's the starting point.